Yeah.
All right, hello everyone. My name is Christopher Rowan, and I'm presenting question 20 for you today. So we're given this set of numbers, 3 minus 6, 12, and minus 24. And it goes on to infinity. And so we're asked to find a recursive rule and an explicit formula, explicit rule for so that we can calculate any term in the sequence. So what it means by recursive is that for some term in the sequence, its value will be given by the previous terms in the sequence. So if I call this set S, and each of these terms is, I call them S1, S2, S3, and so on, then I can simply make a table. I'm trying to figure out in my head how these are mathematically related to each other. So maybe you're really clever and you can just spot it right away. But another thing you can do to sort of help group your thoughts, right, I know you can't see this though, is to start making a table of the values. Yeah, I keep wanting to call them S. We're going to make a table of values, and what we want to look at is the ratio between the next term in the series and the term previously before it. So here I have 3 and minus 6, 12, 12, minus 24. And what I see, so I've got minus 6 over 3, which is minus 2. 12 over minus 6 is minus 2. Negative 24 over 12 is minus 2. So it looks like these are all related by a factor of minus 2. So this essentially gives me my formula here that S of n plus 1 over Sn equals minus 2. Just rearrange, bring the Sn to the other side. I've got Sn plus 1 equals minus 2 Sn. So that's it for the first part. We found a recursive rule for the sequence. Okay, now we'll erase this and move on to the explicit form. So the first thing we notice is that there's these alternating negative signs. So really I can look at this set as being composed of how I view it as 3 different sets. There's what I'll call S1, which is just this alternating negative sign. There's then a set S2, which is really, so when I look at this, I see that there's this factor of 3 that can be pulled out of all these terms. And there's also some kind of increasing, it seems to be increasing quite quickly, which is suggesting some kind of power term. So I notice that it has a factor of 3 in it. So really this is just some sequence of 3's repeating on. And then there's some third sequence which has these powers of 2 going off in it. So yeah, you can observe that there's this set of numbers going off that's causing it to grow up exponentially quickly. So the total sequence, as I see it then, is the multiplicative combination of the first term and then the second terms and so on. So I'll give this like a notation sort of like S, okay. I want to keep these as superscripts for my labeling purposes here. So it's a multiplicative combination of these. And so I can write that some term I, right, this is going up by powers of 2, so I have So I come up with this formula for any I in the set that's equal to or greater than 1. I hope that's kind of clear now. We're asked to find the 10th term, so it's good that we found this explicit formula here that we can just plug in I equals 10 instead of having to go through. If we just had our, if you remember the first recursive rule that I came up with, we would have to calculate all the terms up to the 9th one to be able to calculate the 10. So here we can just plug in I equals 10 and put this in your calculator, and you get minus 1,536. So these sequences are helpful and useful in mathematics as it's a discrete mapping. So we take a number from the set of natural numbers, a set of real positive integers, 1, 2, 3, 4, and we map it to some other set of numbers. So it's a mapping similar to functions, except functions are for continuous changes, and these are discrete changes. And they also lead into series. So if you start wanting to take sums of numbers, it's useful to have some kind of understanding like this, be able to come up with formulas, and then lead into series. So a problem that I'll leave you with, taking it sort of to the next level, I'm going to bring in complex numbers. So I'm not going to use I for the index anymore. I'll use I for the square root of -1, and I'll use j. Well, you can come up with something in terms of j. So the sequence of numbers is 2, 6i, minus 18, minus 54i, 162, and so on. And now I'd be happy to entertain any questions. Yes?
What exactly do they mean by explicit rule?
So from my understanding, explicit means that you calculate the ith term without looking at without knowing any of the previous terms.
You get the formula to represent the...
It's the formula that gives me the ith term directly without having to know any of the previous terms.
So you could figure out the millionth term if you want.
Exactly.
Whereas with the other one, you'd have to work your way through.
I'd have to work through the 999,999 previous terms.
Thank you.
Okay, thank you.